Namaskar and good morning to all. I am Shital Tivaskar, Assistant Professor in the Department of Computer Science and Engineering. It gives me immense pleasure to welcome you all to this prestigious event, the second International Conference in the Sustainable Innovation in Science and Engineering 2025, proudly organized by the School of Engineering and Technology. SOET is the vibrant center for advanced education and research with a strong focus, sustainability, innovation, and industry collaboration. We aim to empower future engineers and researchers to solve real-world challenges and contribute to a better tomorrow. Today, we are honored to host this international platform which brings together bright minds from academia, research, and industry to share knowledge, spark decision, and collaborate on sustainable solutions in science and engineering. A very warm welcome to our respected dignitaries on this dais. Our chief guest, Dr. Sanjay Dhoble, Senior Professor, Department of Physics, RTM, Nagpur University. Our guest of honor, Dr. G.R. Bamnote, Principal Ram Meghe Institute of Technology and Research, Badnera. Dr. Rahul Khokle, Organizing Chairperson and Dean SOET. Dr. Arvind Bodhe, Co-Chairperson of the conference. Dr. Sandeep Petkar, Organizing Secretary. Welcome, sir. To begin this special event, now I invite our respected guest to come forward and light the ceremonial lamp. I request everyone present in the seminar hall to please stand for the Saraswati Vandana.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्.
May I request all student and faculty members to please stand for the university song. Thank you.
ज्ञान की आराधना, ज्ञान की हो साधना, सत्य की एक खोज है गुरुकुल की ये संकल्पना।
ज्ञान की आराधना, ज्ञान की हो साधना,
ज्ञान की आराधना, ज्ञान की हो साधना, व्यक्तित्व का विकास ही समृद्धि की है अल्पना। उत्तरों की खोज में प्रश्नों की फसलें खिले, जिज्ञासा की बीज भी हर एक के दिल में पड़े। ज्ञान के दिन हर जले, अज्ञान की रैना ढले।
मुक्त सत्य की हो कामना, गंतव्य नहीं एक राह है।
गुरुकुल की ये संकल्पना, ज्ञान की आराधना, ज्ञान की हो साधना, सत्य की एक खोज है गुरुकुल की ये संकल्पना, गुरुकुल की ये संकल्पना।
Thank you. As we begin the inaugural function, may I invite Dr. Arvind Bodhe to extend a warm welcome to our chief guest, Dr. Sanjay Dhokle. Thank you, sir. Now, I invite Dr. Rahul Khokle to extend a warm welcome to our guest of honor, Dr. GR Bamnote. Thank you, sir. Now, I request Dr. Rahul Khokle, Organizing Chairperson and Dean SOT, to address Conference on Sustainable Innovation in Science and Engineering.
Chief guest of today's function, Dr. Sanjay Dhokle. Guest of honor, Dr. GR Bamnote. Conference co-chair, Dr. Arvind Bodhe. Dean of School of Science, Dr. Vidya Mishra Madam. Dean of School of Commerce and Management, Dr. Chari sir, Dean IQAC, Dr. Golai, Dean Academics, Dr. Srikant Thote, Dean Research of GHRU University, Dr. Narsimhachari, convener of this conference, teaching and non-teaching staff, and all the participants. Good morning and a very warm welcome to all of you. The second international conference on sustainable innovation in science and engineering is hosted by School of Engineering and Technology, GHRU University, Saikeda, Madhya Pradesh. This university belongs to the Raisoni Group of institutions. The Raisoni Group of institutions, RGI, is well-known educational group in India, primarily based in Nagpur. It has strong presence across several states and offers a wide range of educational programs in diversified fields. It has over 19 institutions and 4 universities located in cities such as Nagpur, Pune, Amravati, and Saikeda. The GHRU University was established in June 2016. It is situated in Saikeda, Madhya Pradesh. It spreads over in 400 plus acre land situated in Saikeda. The international conference provides a platform for sharing knowledge, research, and innovation. The theme of our conference is sustainable innovation. Sustainable innovation aims to address current challenges to protect the ecosystem. Because when we talk about any innovation, any research, then it should not have its other effects also. So whenever we go for innovation and research, we have to ensure that it should not hamper the ecosystem. That is why the sustainable innovation, sustainable development is very important. Sustainable innovation is required in almost every field of science and engineering. It is required in computer science and engineering. It is required in mechanical, civil, mining, everywhere the sustainable development or sustainable innovation is required. We have received almost 160 research papers to this conference, and the papers we have received from various parts of the country. Out of these papers, we have shortlisted 80 papers for the presentation of this conference. This conference is also accompanied with poster presentation and model making competition, which will be held tomorrow at Saikeda campus. So almost 140 participants are there who are participating for poster and model making competition. Today we are very fortunate to have the eminent personalities like Dr. Dhobre sir and Dr. Bamnote sir. Dhobre sir is having very strong research background. He has almost 18,000 citations in Google Scholar. 57 he has H index and I think 487 I-10 index. So very strong background he is having. Dr. Bamnote sir is also an academician and researcher. He is also having a very strong background, and most importantly, he is my teacher also. He taught me in my engineering as well as my UG and PG. So we are very fortunate to have these Bamnote sir as the today's guest. I welcome our another guest of honor, Dr. Nilesh Singh Thakur sir. So I welcome Thakur sir to this inaugural function of this conference. So I hope that this conference will come with some fruitful outcome of the research. So the participants will present their research papers, and some fruitful outcome will come out as an outcome of this conference. So I wish you all the best for this conference. Thank you very much.
Now, I invite Dr. Samayak Parekar sir to extend a warm welcome to our next guest of honor, Dr. Nilesh Singh Thakur. Now, I invite Dr. Suhasini Dafe ma'am to extend a warm welcome to our guest, Dr. Raju Belekar. Thank you, ma'am. Now, I invite Dr. Samayak Parekar for the convener speech.
Good morning and very warm welcome to all the dignitaries, esteemed guests, keynote speakers, national and international advisory boards, session chairs, paper presenters, research scholars, faculty members, students, and participants joining us for second international conference on sustainable innovation in science and engineering, that is ICSISE-2025, organized by School of Engineering and Technology, GHRU University, Cycle. It is indeed a moment of great pride and honor for me as one of the convener of this international conference to address this adverse and scholarly gathering. At GHRU University, we believe that the pursuit of knowledge must always align with greater good of society. This belief is deeply reflected in this year's conference theme, that is sustainable innovation in science and engineering, a theme that not only aligns global priorities but also challenges us to innovate responsibly and ethically. We thrilled to welcome speakers from leading institutes who will be sharing their insights into emerging trends, sustainable technologies, and transformative research. Let me now briefly walk you through the conference schedule. Day 1, that is 6th May. The conference is being conducted in hybrid mode with inaugural session and keynote addresses held offline at RIAAN Tower, Nagpur, as well as online via YouTube live streaming. We begin with the inaugural ceremony graced by Chief Guest Dr. Sanjay Doble sir, Guest of Honor Dr. G.R. Banmote sir, and Guest of Honor Nilesh Singh Thakur sir. This will be followed by a series of keynote sessions delivered by renowned experts both offline and online, covering cutting-edge research in science and engineering. Day 2 of the conference, we are delighted to provide this platform for researchers, young innovators, and academicians to exchange ideas, collaborative, and inspire one another. The second day takes place at GHRU University campus, Saikeda, featuring parallel online and offline paper presentation session. Over 80 research papers will be presented by scholars from across disciplines, including sustainable material, AI, structural engineering, sustainable development, and digital innovation. In addition to technical sessions, we are also hosting research poster competition and model making competition, providing platform for young minds to showcase their creativity and practical insights. The conference will conclude with valedictory session where we will reflect on the knowledge shared, recognize outstanding contribution, and celebrate the collaborative effort that made ICSISE 2025 a grand success. I take this opportunity to thank Honorable Vice Chancellor Dr. Meena Rajesh Ma'am, respected Registrar Dr. Sriram Joshi Sir, Dean School of Engineering and Technology Dr. Rahul Khokle Sir, HOD Civil Engineering Department Dr. Vishal Gajgate Sir. I also thank convener team, organizing committee, volunteers, speakers and participants for their unwavering support and commitment. Let us together make ICSISE 2025 not just academic event but milestone in collaborative sustainable innovation. Thank you once again for your participation and I wish you an intellectually stimulating and productive conference. Thank you.
Thank you, sir. May I request Dr. Jatin Sadarang, sir, to present a brief introduction of our guest of honor, Dr. G.R. Bamnote.
Good afternoon, everyone. It is my honor to introduce a distinguished academic and inspiring leader, Dr. Gajendra Rambau Bamnote, sir. He is currently serving as a principal and professor in Department of Computer Science and Engineering at Professor Ram Meghe Institute of Technology and Research, Amravati. With over 34 years of teaching experience, Dr. Bamnote sir has made significant contribution to engineering education, particularly in the area like real-time database system, artificial intelligence, and machine learning. He has guided more than 15 PhD scholars and 75 MTech students, shaping the future of research and innovation. A recipient of prestigious national awards, including the Raja Ram Bapu Patel Award. Dr. Ram Notice sir works brilliantly both academic and including and excellently and practically innovations. His contribute including patents and research publication have had a lasting impact in the fields ranging for data mining to healthcare prediction models. Please join me in warm welcome to Dr. G.R. Bamnote sir. Thank you, sir.
Thank you, sir. May I request Dr. Arvind Podhe to present a brief introduction of our guest of honor, Dr. Nilesh Singh Thakur.
Thank you, madam. Chief guest of today's conference, Dr. Dobre, guest of honor, Dr. Bamnote, guest of honor, Dr. Nilesh Singh Thakur, sir. I welcome you all. It's my privilege to introduce the guest of honor, Dr. Nilesh Thakur, sir. Dr. Nilesh Singh Thakur, sir, is graduated in CSE, Computer Science and Engineering from Government College of Engineering, Amravati, He also postgraduated in CSE from the Amravati University and the PhD from VNIT. Sir have near about 32 years experience in a field, in the area of HOD, professor, dean, principal in various colleges and university also. Sir having 100 plus technical papers in reputed journal in international conference also. Sir edited 3 books published by Spinger and Tata McGraw-Hill. Sir awarded 3 patent and 3 patent in published. Sir guided near about 8 researchers in the field of computer science. Sir delivered near about 90 plus expert talk and 21 keynotes speech in various international conferences. He also worked as the editor board of 9 reputed journals. Sir served as a technical program committee member of 32 conferences, which is held in Spain, Canada, Ireland, then Canada, Germany, Australia, Thailand, Malaysia, Japan, UK, and so many countries. Sir is affiliated member of IEEE. Sir is member of the IST India, INJE, and IJE in computer science. With this word, I welcome you, sir, for the conference. Thank you.
Thank you, sir. May I request Dr. GR Bamnote, sir, for inaugural speech.
Thank you, madam. Dignitaries on the dais, the chief guest for the inauguration session for this second international conference on sustainable innovation in science and engineering 2025. Dr. Dobre sir, Dr. Nilesh Singh Thakur sir, the guest of honor, the coordinator for this conference, Dr. Rahul Kokle sir, Dr. Bodhe sir, Dr. Parekar, the convener of for this conference, Dr. Petkar, Madam Dr. Dafe, all the dignitaries sitting off the dais, dear participant and dear students. I'm really honored to be part of this international conference on sustainable innovation in science and engineering 2025. And let me thank the organizers for inviting me here and making me part of this conference. I should appreciate the organizers for bringing this appropriate topic of relevance for discussion on this platform. And as we know, sustainable is not a technical term. It touches our heart. It touches how we live, how we grow, and how we take the care of our planet. And when we talk of sustainability, it is not just the technical term, but then it has become our responsibility. And we have experienced that there had been many changes, tremendous progress. When we talk of, say, the giant dams which we have built, the fast vehicles, and then the chemical fertilizers or the plastic products that has made our life easier. It was when the dams were built, it was out of reservoir. We wanted that the water should be stored and then to generate energy. And with this, we had all the dams. We had the use of chemicals so that we have a tremendous growth in our crops so that we can feed a number of our population. We had innovations in say plastics or packaging so that our utilities, our packaging, our life becomes easy. And of course, those chemical fertilizers so that production is increased and we can feed our large growing population. But then this has brought some problems with it. For example, if you talk of dams, though they were created for storing water and then generating electricity, but along with that, we have seen that they have created lot many problems. We have to lot many people they were dislocated, and then the ecosystems had been changed. When plastic came for our comfort, but then we have seen that there have been disadvantages now. The ocean that is then again is full of the plastic, and our ecosystem, the animal habitat that has been disturbed, and then resulting in our own, what to say, our life cycle. And now we should talk of just not for innovation, but then we should also talk of sustainability. We should talk how we should make this planet a better place to live. And I think this conference will be a great platform where we will be discussing all this. And these terms, when we talk of sustainability, maybe from few years we are talking of sustainability, but then in our ancient Indian wisdom also, those people, they have taken care of this. When we saying about Ayurveda, when we were in the boardroom, we were discussing about Ayurveda, and then there are a lot many advantages. Ayurveda, it also says, Yaha Pinde Saha Brahmande, means what is inside our human body, it is similar to what is outside. So thing is, they have thought it in advance that if you disturb nature, naturally our health will be deteriorated. It will disturb the human body, us, or it will reflect the same thing in your life. So we should take care of sustainability. Whenever we innovate, see to it that it is not just for profit, it is not just for comfort, but then it should be there for the planet, for the society. And as I am from computer science and engineering, so there also we talk of sustainability. We talk of the green servers, where nowadays it is said that AI and all this, they come to your help, where you can save the electricity, you can save the power, maybe in the cooling of the servers, and by then you can make it more sustainable. You can have many devices, you can have the IoT devices, you can have sensors where you can save electricity by means when it is in use, when you are there, it will be on, or when you are not there, maybe those devices will be off, and as you save the electricity, you save the carbon emissions. So you have efficient power homes. There are many means using AI where you can recycle the waste. You can categorize those waste, you can recycle those waste, and then it can be used. Earlier it was, they used to say that it is from cradle to grave. Now it is cradle to cradle, so that you can reuse whatever you produce. Maybe you can reuse it. You can again reform it, and it can be used for better. Many times in computer science, we said that the code what we use, it is always a rat race, and then we are going for a code, we don't think of making it optimize. I have a Samsung Galaxy phone, and then few days back I was told to update the app, the State Bank of India app. And once I updated, it said that your phone is now outdated. Thing is, it is asking for a new hardware. Your programs are asking for new hardware without optimization. And thing is, because you are adding the code, you are just putting the codes so that your product will come first in the market. But we as computer science students should think of optimizing this code. We should think of how those devices can be updated without changing the old device. I need to change, if I want to install the app, which I said, say, app, then I need to go for a new product, a new mobile phone. But then instead, if you have, as we had earlier, we used to assemble those computers. Now, if you can give those in parts, if you can think of sustainability, you can allow the products, instead of replacing them, you can reuse those products. So, dear students, see to it that you take a lot from the discussions which will be here. We are really fortunate to have the chief guest, Dobre sir, who have lot of experience. Lot of experience not only in physics, but then when we were discussing, even in Ayurveda or other science. And he talks of sustainability. Another researchers we have, Dr. Thakur, who is a friend of mine. And then from so many years, I have watched him, not as only as a friend, but a student and then a colleague and a researcher. So participants, you are really lucky to have those keynote speakers who will be sharing their knowledge. So whenever you go for any innovation, whenever you go for any project, see to it that instead of seeing that what I can build, can I build this? Think of, should I build this? Will it be giving me a temporary solution, or it will be of any help? It will be of help. It will be make the life of the people better. It will make the planet a better place to live. So let us pledge that we should innovate for making the planet good, making the society good. And I think this 2-day conference, which is in online and offline, the hybrid mode, will be a very successful, where the participant will be sharing a lot and then getting a fruitful inputs for this. And with this, I once again thank the organizers for making me part of this conference. I'm really grateful to the organizers, and at the same time, I wish you a very fruitful conference, 2-day conference, and my best wishes. Thank you. Thank you very much.
Thank you, sir, for his valuable speech. Now, may I invite Dr. Sanjay Dhopli to give inauguration speech.
Good afternoon. Today I am very happy. I am part of this international conference, Sustainable Innovation in Science and Engineering, and we are considered this is the maybe in technology. Very nice person sitting on the dais. One of the is Bam Lode sir, Chauhan sir, and all energetic faculty of the RIAAN group. Really, I am happy. This university in the Saikheda. Saikheda is a very small city, small village, not city. and I am very close to the Saikeda, my hometown, only for 10 kilometers from the Saikeda. And today I'm very happy they are inviting me as a guest and keynote speaker. Really, sir, I'm very happy for all of you inviting me for the very, very close university from my town. Today is a very difficult condition for me. Both guests is the for computer science. One sitting that side, one sitting another side, and I'm sandwiched between these two computer technology. But both sides is the same type of the material, and in between is the another material. So this another material always activated, and this is called the innovation. So I'm trying. One time is the AI, another side is also AI, but I'm working on the machine learning very good way, and my one of the paper is published in the machine learning language, sir. I'm really happy. I'm doing some work only for my student. I've so many times discussed with my vice chancellor of my university. Sir, I'm working for my student, not for me. So any idea coming in my mind, first I'm discuss with my student, and just you come and elaborate this problem, and just we are going to the patent. So today is my 106 patent, 1106 patent now. So why I'm concentrated on the patent? I'm interested my student always in the good job. And if my student in the line of this interview, so I think very few students have the patent, but my student have the 1 or 2 patent. So this is the first or second rank, and maybe he's joined this industry or any type of the institute. And I know that all engineering colleges require the patent, paper, chapter, and books. So my maximum students on the good engineering and technological university, and sir, really, some of the students get the more than 90,000 rupees per month salary. And government salary is also nearby to the 90,000, but you know that what is the picture of the government aided college is required the 75 lakh rupees donation. But I'm just consider my student, you don't give the donation, you work for the paper, publish the paper on the Scopus, you publish the patent, and you are freely, you can join the private engineering college and our university. So I'm always trying for my university. And therefore, I'm not consider so many my paper, but I'm not in any paper the first author. My student is the first author in the patent. First authority is my student. I'm already senior professor. I don't want to the any type of the label, but my student want to the energy. My student want to the academic CV. So she is or he always is the first author, and full credit goes to my student. If this type of the tendency you can create for every teacher, so I think our education policy is the very best. But nowadays it is a very big problem, students not interested in the research. Why? Our research is not directly connected to the industry. In abroad country, everyone is the research project from the industry, but in the India, very less industry. In the Nagpur itself, very few industry. So our student not directly connected to the industry, but then we are creating the good biodata, so he may be possible to job in anywhere in the place of the India or abroad. Presently, my 16 student in postdoc fellow in abroad. I'm not getting any postdoc fellow during my student life, but I'm giving this chance my students. So this is my work, and I'm not explaining much more. My talk invited, keynote address after my this inaugural function. So I'm just stop here, and sir, really thanks you are organized this type of the conference, and I hope all students change your mind setup. Mind setup आपका कैसा होगा? कोई भी चीज को देख लीजिएगा, उस चीज को देखने के बाद अपना माइंड सेटअप में वो पिक्चर इमेजिन कीजिएगा, और इमेजिन करने के बाद व्हाट इज द रिक्वायरमेंट ऑफ योर दिस वर्क एंड व्हाट इज योर टारगेट, एंड यू कैन मिस मैच बिटवीन दिस 2 पॉइंट, एंड जस्ट यू कैन अप्लाई द रिवर्स इंजीनियरिंग एंड क्रिएट द वन फिगर. सो दिस इज द न्यू आइडिया ऑफ द पेटेंट इज पॉसिबल. तो हम वही पेटेंट करते हैं जहाँ पे हमें अच्छा लगता है. और मैं एक ही सेंटेंस बोलूँगा सभी स्टूडेंट के लिए कि हम जहाँ से सोचना शुरू करते हैं, जहाँ से लोग सोचना बंद करते हैं. Thank you. Thank you very much.
Now, may I invite Dr. Vishal Gajghate sir to present a memento to Dr. Banmote sir. Thank you, sir. Now I kindly request our chief guest of honor, and all faculty members, please come in front of stage from a group photograph. Now I would like to invite Professor Rati Raghuvanshi to take over the continue this session. Good morning, one and all. Before moving forward, I would like to introduce myself. I, Rati Raghuvanshi, Assistant Professor in the Department of School and Science. It gives me immense pleasure to welcome you all to this prestigious event, the second International Conference on Sustainable Innovation in Science and Engineering 2025. Now, we are ready to begin keynote session 1. With great pleasure, I invite our esteemed chief guest, Dr. Nilesh Singh Thakur, to step forward and deliver the keynote speech for the first session. Sir, the platform is yours.
चल जाए ये Very good afternoon, everybody sitting over here. With immense pleasure, I would like to thank the organizing team, along with the today chief guest, Dr. Sanjay Doble sir, Dr. Gajendra Bamnote sir, and complete organizing team from GHRU University, Saikeda. I know most of the faces, Dr. Rahul, Dr. Arvind. I'm going to talk on, being the conference is on sustainable innovation in science and engineering. Now sustainability, it become a liability for one individual. Even animals surviving for sustainability, humans are surviving for sustainability. At the same time, whenever any technology comes down, it also survives for sustainability. Now, why the people are talking about the sustainability nowadays? And from last 2-3 years, many huge international conferences are organized related to sustainability. The UN in 2015 decided to go for 17 sustainability development goals. Being we people are from education, the SDG number 4, it is associated with the quality education. And the very last one, 17, is associated with the collaboration, or you can say partnerships with some other people to address the sustainability. Today is the age of artificial intelligence. Everyone talks about the artificial intelligence, irrespective of your stream, whether you are from science, engineering, or technology. Whatever your degree is, everybody is going to use the computer. Everyone is talking about all these things. But when we do go for all this, there are two things. One is the fashion, other one is the core value. Taking in consideration the fashion, what are you doing? I'm working on this, using AI. I'm working on that, using machine learning. But what to do? Everybody deals themselves that they know each and everything, but the fact is what not to do. Nowadays, everyone is going for the huge data collection, data generation, and the processing. My talk is focusing on how can the AI can be revolutionized by using the nature phenomena concept, that is the fractal, and how it can introduce the parallelism and how you can get benefit of parallelism from AI implementation point of view. Here the whole talk will move around all these 4 points: fractal computing, AI advancement, parallelism impact, scalability, and efficiency. Now when it comes to efficiency, finally you are landing on the sustainability. If you don't know the fractal, whatever the clouds you watch in a sky, it is basically a fractal. You cannot define a shape of any cloud. But if you compare the 5 photographs of the cloud, you can able to measure the similarity between them. This is what the nature. If you do see some hill station and click the photograph, you will find that all around all the hills are having the same similar pattern. Only size may differ, density may differ. No, this is what the nature is. Even son and daughter like a father and son and daughter like a mother, we used to say there is a similarity. So see, all this one is the natural process and we cannot ban or challenge the nature. In a technology, if you do incorporate this natural happening by some means, so ultimately the roots of my talk, it is associated with the similarity and that too the self-similarity. Similarity within yourself. In Adhyatma, we used to say, or most of the time it happens, कि मैं ये करना चाहता था लेकिन मेरा दिल वो बोल रहा था, एक मन ये कह रहा था, दूसरा मन वो कह रहा था, मन तो एक ही है. But why do we say like that? Some people may represent this thing, antaratma, atma and all that. So ultimately there is a something within ourselves like that. Always whatever the problem you are going to solve, if you break down that problem, you will find the self-similar problems are existing there. Most of the engineering, science or any sort of problems or the real life problems are always in a non-linear, in a nature. Nature of the problem is always non-linear. But how do you conquer this non-linearity? What are the mechanisms or the technology algorithms which are available? Most of the algorithms or all of them, their root lies only in a linearity. Circle equation is x square plus y square is equals to 16. Line equation is x plus y is equals to 14. Difference is of what? Only the degree of polynomial. If you explore the circle, if you go, it is made up of arc. Arc is made up of small line segment. And what line segment is? It is a x plus y something. So ultimately circle is made up of lot many linear problems. Support vector machine is the known algorithm which handles the non-linear problem. It basically works on linearity. Being a student of computer science engineering, studied algorithms, dynamic programming, always you have to break down. It's not like that the dynamic programming only get adopted by the computer science engineer. Even civil engineer student too. They used to break the problem into the different parts, then they rule. And later they integrate the things and evaluate the whole stress strain analysis. Even in a mechanical, some iron rod is get hammered, how the heat transfer get going to happen. So material will come down, physics will come down. When I was a student, there was a thick line. Civil, mechanical, electrical, computer, electronics, all were different. But right now, even you can't able to identify that line. It is so thin. So what the computer, mechanical, electrical students are going in computer science industries. What I mean to say, to address the issue of sustainability, our root, being an engineer, being science student, our root lies in a computation. Because whenever you go for any implementation, your whole computer system is running on electricity. Now we have to go to the root. You are requiring much more energy. How can you save the energy? The only way is there, that is what the parallelism. I will go through the next content. Now here the fractal computing, you can see in a center, it is a geometric inspiration. I will quote few of the examples. For example, a neem tree, or take people, any tree. You will find all leaves are of same shape. Their size may be different. Stem may be bigger in a width. Branch may be thinner in a width. Length may be anything. So why to record or take a whole picture of the neem tree? If I keep some dimensions, one leaf design, then I can utilize the different transformation to generate another big neem tree. Same leaf may get translated from this to this place, may get resized in a size, maybe smaller or the bigger, may go for some rotation, and in that way you can able to explore. Right now, if I do click some photograph from this place of audience, I will find one pattern. Every chair, there is a cover, and all covers are near about same. If I'm going to click a photograph, if some chairs are vacant, why do I send the whole data? Why should I send the whole picture? I can explore the self-similarity. I will minimize the data and I will communicate that one. So ultimately, traveling of data is also requiring some energy, because when you are transmitting through your channel, at the receiving station, it may require some energy. Now, in that way only we can able to contribute as a science student, technology student, and engineering student. So fractal basically talks about the self-similarity, and the root of that one lies in a geometric representation. It is basically iterated, functions are get used, which are get recalled again and again. It is what called as the IFS system. Through that one, it can be generated. Fractal images can be generated. Now here, how do it help for the scalability and adaptability? You can see, if you are handling some problem, maybe I do take, being it is a multidisciplinary conference, if I do take a design problem in a mechanical engineering, if you are going to make a design, always you have to go for finite element analysis. You have to break down the whole complete geometry into small part, because you are going to choose one of the material from the 5 material. And when you are going to do that analysis, at that time you are going to evaluate if at this particular node something is happening, how does it affect to the adjacent nodes. Nodes means you have to divide the whole geometry into the different part, maybe triangular shape, maybe square shape, maybe with some certain points, and those intersection points are the node or at what you are going to evaluate your all stress, strains, and other heat transfer analysis. Now, when you are going to that one, you are going to get the huge number of data. If you are going in a sequential manner, then there is a problem. You may require more time. More time directly proportional to energy consumption. So how can you save your time? So of course, you may go for the parallel processing. You may go for distributed system. But here itself, if you are breaking the problem into the parallel parts, and your algo may run for 1 bit, and which is going to happen at the different places, automatically your time will get minimized, and due to that one, energy consumption will be less. And how it is helping for the parallel processing, as I told you, if you do take the one image or any problem, if you break down that problem into the sub-problem, 100 problems, you have to identify whether problem 1, sub-problem 1 is similar to any other problem. You will find that, yes, it is similar. Even in our mathematics, we used to see when some algorithm or method 1 get enhanced by some other researcher as a method 2. Method 1 consists of 10 steps. Method 2 consists of 12 steps. Out of these 10 and 12, 6 steps are same. So where the difference lies? Difference lies in other additional 6 steps. So why I am solving all these problems independently? Can I not do the same thing at the same time? Yes, I can. That is what the fractal, being it's a natural concept, but we have to explore. Later on you will find in some slide how to drop the problem. So here, the typical point is the program scalability. and the productivity boost. Now, once you have developed some mechanism associated with the fractal computing, how can you make it scalable? That program, when I was a student and Bamnote sir was student, at that time we used to learn the procedural languages. We were not allowed to go for some sort of off-the-shelf programming. At that time, mechanical people used to say, we are manufacturing this and that. But we were not in position to say at that time, we are manufacturing the software. We used to say, we are developing the software. But nowadays, I can able to say that I'm manufacturing the software. How? Manufacturing may be assembly line evaluation, collecting the components and making a product. Now, is it possible? At that time, when I was a student, it was not possible. But nowadays, I can manufacture a software by taking the different software components and putting them on an assembly line. And so what? There is a one concept in a Python. People talk about that programming line and all that. How you are going to collect the things. Due to the introduction of object-oriented programming, off-the-shelf is possible. Just to open the Almira, take out something from that cupboard, use it. Once your work is over, keep that copy there. What the industry is doing? One industry handling some XYZ bank software automation, they may get the second client, ABC Bank. How do XYZ Bank and ABC Bank will be different? Around 70%, their mechanism remains same. So industry is not investing a labor hours in those 70% development. They are taking the previously developed components, and all this is possible due to the object-oriented database management and object-oriented programming. So off the shelf, now when you come to the fractal, whatever the program you have written, how it can become a scalable. Scalable and adaptive, both the things are different. My problem size is 100, I have written program 1. Now problem size become 10,000. Whether my program 1 is capable to handle 10,000, then it is a scalable. If it is not so, then it is not scalable. Now, adaptivity, if any complexity increases in a problem, if my algorithm is able to handle that one, then I can say that my algo is adaptive. So, those who understand adaptability, scalability, there is a huge scope. If you do compile something or write something in a fractal computing, you can able to go for the scalable programming. Next. Here you can see how the parallelism in a fractal computing affects the thing. Inherent parallelism, then enhance AI training, and optimize AI algorithm. Lot many people, nowadays it became a fashion to work with the AI. People writing a title, student is always student. It is up to the teacher to guide the student whether he is right or wrong. You have to give some corrections even to your research scholars. Research scholar used to come that I want to work on this, that problem using AI. But when AI comes down, unless until problem is not complex, there is no meaning to AI. And students do what? They don't try to go for the complex problem. Now, being the problem is not complex, no need to go for your AI implementation. You can work out the thing, something by means of your ML, machine learning algorithm. It is just simply a stata manipulation using some methodology. People used to talk about the training. People used to talk about the testing, then validation. Even that is there in artificial intelligence. When I was working in a neural network a long back, in a 1997-8, I have started to work in neural network. After some time period, I hold down. I was not working in neural network because I found that lot many people are people were not working in a neural network. Now, whatever the AI nowadays happening, it is based on DL only, deep learning. And deep learning is completely based on the neural network. But nowadays, hardware does not remain the big issue, but still it is the issue. A point will come because the fractal computation, when you want to go for the implementation, in the case of training, you have seen like huge data is there. If you want to train some model, and if you are using a simple laptop, it may take a number of hours or days. In that case, you have to go for super level processor. Now, super level processor, you do have a center of excellence, NVIDIA system, then and then only it is possible. But it is not affordable to one individual researcher. Then what he can do, so he used to go with the batch submission. Data, batch submission and processing the data. My question is that, yes, you do follow the same mechanism, but apart from that one, if you do introduce the fractal over there, you can able to minimize your data. The bigger question mark is there, what data you want to use. Generally, it is my personal opinion, and I'm confident enough, there is a big misconception amongst the researchers and even our teacher fraternity. If somebody want to work on something, teacher or student used to ask to each other, sir, data is only, I'm having 100 records. Teacher used to say how it is possible to train the model in 100 records. We may require 1,000, 10,000, 20,000. And whenever the student and teacher gets those 10,000, 20,000 records, then they become happy. Ultimately, we are doing what? We are not taking care of the pollution what we are making by collecting the garbage data. So some or other way, what to use and what not to use, unless until if somebody will not understand, then there may be a big problem about the sustainability. Now, the fractal computing is going to address this issue and which will optimize your AI algorithms. Scroll. If you do take the comparison or make the comparison of our traditional computing mechanism as what just now I have quoted, the high level NVIDIA system processors, of course, it will create an impact of high level. But if we do go with the fractal computing, of course, it will be slightly higher than what is existing. Here you can see the advanced computing models, the complex problems, which is offering the innovative solutions for complex computational tasks. I'm recalling when we were students, or even nowadays also, around 5 or 6 years back, one revolution took place in our Maharashtra about engineering admission. When we were students, at that time, physics, chemistry, math was the basic criteria to take the admission. Then later on, CET is introduced. Still, it was there with physics, chemistry, maths. There is no any role of biology. There is no any role of biology. But whatever the AI is happening, it is happening only due to the biology. Biology of brain. That is what neuron, neural network, then artificial neural network, many number of layers, input layer, output layer, hidden layers, more number of 1,000 number of neurons, and finally you got a mathematical representation of your problem. So there is a role of biology, and nowadays in autonomous institutes and some IITs, NITs, the mathematical biology, named subject is introduced. This is what very necessary. So biological thing we have to understand, and the complex computational task. Whatever the problem you are facing in a life, make a list. Whatever the problem you are facing, technically make a list. Now two lists are there with you, and then make two lists about your friend. Do describe him on one page, other friend describe him on other page. You will find that you may be in position to solve the technical problem, your personal problem, but it always becomes difficult to describe your friend, because you will find that the huge complexity. Friend doesn't mean a one individual human being. Our human body system, it itself is a complex system, a complete complex mechanism. Now this complex mechanism, the robotics is get introduced. Now we are calling some robot is talking, walking, working, doing all the things, giving you the emotions. So that machine is started to behave just like a human being. So human being, it itself is a complex. And unless until if you are not having a problem of that sort of, you are not in a position to apply the AI. Now here, as I told you initially, within human, there is a similarity within. Right palm shape may be similar to left palm. Right leg shape may be similar to left leg shape, may be differ by something. But around your body, it is a completely asymmetric body. If you vertical left hand, right hand side, if you do observe, it is similar. So straightforward one similarity is there external. If you go in an internal side, still there is a similarity. If you do see the biology of all these things, you will find at lot many people, even within an organ, there is a similarity. Now connectivity mechanism is completely non-linear. It is not series connection. Somewhere series, somewhere parallel. It is a series parallel, a hybrid connection within inside. Now, when we are going for the fractal implementation, you can able to implement that similarity, and based on that one, you can design your own model. I used to say my student, refer everything whatever is available. Come with something which will be different from the existing one. But confidence is not high. It doesn't matter. What are you doing? You may be succeed or may not. Not succeeding, it is also a research. And succeeding is also a research. At least not succeeding, you will be in a position to tell the globe that this is not possible in this case. It is a research. But misconception, always try to have better result than somebody else. It's not like that. If you are not getting better, but why your results are lacking, if you are able to debug that one, that can be your outcome of your research. Scroll. Scroll. Now see here the parallel computing. I will not go in a much more depth. Those who are the computer student, even we used to do the parallel processing. Multiple times we are going to handle the multiple tasks. Only from implementation, computer implementation point of view, there are three types of parallelism exist. You can do the task parallelly. You can handle the data parallelly. And third one is, in a computer, ultimately the instruction macro programming is get worked out, and there you can able to give the parallel instructions. So parallel instruction, it is the ILP, then DP, and other one is the task parallelism, that is the TP. How the parallel computing is taken care of? In the first case, the data may get shared by the same similar space. As now Arvind was telling me, I asked him that why you are not organized there, Saikeda. At least I could get chance to visit. So he told me that, all of us came down here. So this is what? This is the shared memory. This is a shared memory. And other one is the distributed memory. Your whole campuses are distributed at different places. Everywhere everything is going on in a parallel. So this is what the parallel computing is. And third one, it may be a not a hodgepodge combination, rather a well-defined mechanism which may include the shared as well as the independent memory. That is what the hybrid approach is. Now, see, the important thing is the different challenges, because even in a fractal, even in a parallel computing mechanism, there are different challenges which you may have to face: the synchronization and communication overhead. Now, how do you can able to synchronize the thing? Whatever I know, and about the Raisoni group, you used to get some instructions from higher office, that campus, that campus, that campus, and we used to, because once I was working with the Raisoni group, maybe for 9-10 months I was there. So everywhere the people are doing the same thing and may inquiring to each other, how you are doing, we are doing in that way, you are doing in that way, no, it is not correct, make this correction, etc., etc. But at the top level, they have to manage all the thing. And ultimate result, sometimes it may happen. Even the HOD gives the task to different people. He has to synchronize lot many things and always face the problem. So that synchronization problem, it always happen. And other one is the communication, dependency and the relativity of the data. That can get managed in a proper way. That is also one of the challenge. Load balancing, you cannot put some load, because used to subordinate used to say, sir, you used to ask me to this, do this and that. You are not asking to that fellow. So it is up to the leader to manage all that. So in parallel computing, how you are dividing your task and all that, that should be taken care of. And the last one is the scalability. Your mechanisms always should be scalable irrespective of your data size. It should not be fixed one. And typically, the fractal computing implementation, there is a big concern about the hardware and the software requirement. As I told you, hardware requirement, why there is a concern? Because you are going for the parallel implementation. I'm having a single laptop and I want to implement fractal. I may face the problem. What I will do, I will take 3 friends' laptop and I will make a network of 4 systems. And within 4 systems, I may distribute the things to 4 systems. And based on that one, I can evaluate. Based on that, I can able to evaluate or evolve my hardware. Even if I would like to have a one system, it may not be possible. So hardware concern is always there. Then complex software concern. If you do take the example, as my talk is associated finally landing on the AI, utilization of fractal computing to make the revolutionary AI by using the parallelism. Now, if I want to that one, I may require some specialized software, some tools. Nowadays, everybody is clicking a photo, going to editor and changing its brightness, making it as a DP. But originally photo, that person is not like that. So what is this? That is what a tool you are utilizing. One algorithm is working behind it. Like that, some facilitation has to be created. That is what the another challenge. And resource intensiveness. I may be in need of lot many resources to take care of. Of course, my final energy consumption will be less. So how can I go for the fractal parallel computing? I want to utilize the fractal and I want to work out the parallelism to facilitate my AI implementation. So 3 areas where you can go for high performance computing can be worked out by using the fractal computation. You can able to do the big data analytics. I used to tell my student, or even those who are working in a data science, they do know whatever the data is available, it always follows some pattern. Now, when you are going to recognize that pattern, it is what? If it is not a supervised data, unlabeled data, you are going to identify what pattern is existing there. Now, that pattern, how can you debug that pattern? Ultimately, it is a similarity. And you want to search out that pattern within that population. Now, the same similar data came from Chandrapur. One data was of Nagpur, and other data is from Chandrapur. Once I got a pattern here, I may would like to see the same pattern if it is existed there in a Chandrapur data or not. If I'm getting the same thing, it itself means that there is a similarity between Chandrapur data and my Nagpur data. Based on that, I can able to sort out that these two data, though it is from different population, but the whole characteristic of population may be similar. So what I can able to correlate Chandrapur data with the Nagpur data, and somewhere I can form a cluster of Chandrapur and Nagpur. But at the same time, I'm having a Bhubaneswar data, I may not find this pattern. I'm telling you the problem of classification. Though my examples are not that much specific, I can't go for that one. Otherwise, it requires a huge time. So ultimately, what I want to communicate, you can able to explore that self similarity amongst the existing data, and through that one, you can able to do the bigger data analytics. Whatever the size of the data, you can able to carry out the data analytics. So ultimately, your fractal computing for AI, of course, I talked about the scalability. Then pattern recognition, just now I told you, how can you able to evolve the pattern recognition? And the important one is this, energy efficiency gains. Here, fractal computing presents the potential for energy efficiency gains in AI system, contributing to sustainable and cost-effective operations. So as you are going to identify a similarity within, of course, this enlightenment in Adhyatma, what that enlightenment is, something you have recognized within yourself, and that is what matching with somebody else. You got some pattern within, and to locate that pattern, it is a very big question mark. The same thing is there about our technical problems. So we can able to incorporate the fractal computing, and if you want to solve any problem, irrespective of your stream or irrespective of your discipline, basically you have to go for these 4 points. You have to identify the potential strategies. How can you incorporate and integrate your fractal computing in AI system? Then implications for software development, and third one is the hardware. What sort of software requirement you would like to have? If it is not available, what particular components you have to generate? And the similar way, you have to go for hardware. And the training methodologies, the supervised learning, unsupervised learning, then semi-supervised learning, transfer learning, reinforcement learning. Many times we used to encounter with these words, applicable to any type of engineering. But only we are talking about the learning. Always when learning happens, when training happens, then learning happens. If no learning happening, then there is no meaning to the training. So the term is the training, which we used to use, but at the same time, I'm a teacher, I'm teaching to the whole class. I have completed one topic in a 15 minutes. I have to keep on asking me, I'm teaching, are they really learning? I have to ask myself. And I could recognize that some typical step, I could make a guess student might not have understood. I got the error. And then automatically, without asking, I'm repeating it. Now, I'm providing a training, I'm checking other whether they are learning it or not. At the same time, I'm evaluating my training algorithm. And the big question mark here also exists. Student or the researcher used to go with the ready, steady, go training algorithm and blindly adopting it and applying it on a data. But who will take care of really the training is going on or not? So people used to say training error is less. Sir, mera training error less hai. Means I did a training in a good way. but ultimately root lies in a testing error. If your testing error is less and comparatively training error is high, no issue. But if your testing error is high and training error is less, it is the biggest issue. We have to be very much careful about that one. You can go with this. So ultimately, the future implications of fractal computing on AI, that is unleashing transformative possibilities, industry adoption and advancements, and through the fractal, you can able to improvise the capabilities of computing mechanisms. Through what you can able to evolve the AI. Presently, the scenario, the whole globe scenario is that how many people are working there and what sort of problem they are solving by using the fractal computing in a AI. Here you can see the healthcare around 22.38. Huge data is available. But whether we have replaced the human being, not yet. Still, we require the human being over there. It's not necessary that always the machine will produce the correct interpretation or the correct result. Here, you can go with the financial analysis around even autonomous vehicle industry. Tesla, all of you know, unmanned vehicle. Now, unmanned vehicle is what? It is just like some human being is sitting over there who is driving a car. It is a very big, complex problem. Without man, you are driving a car. So you have somewhere you have developed something just like a human being who is taking care of. That is what the real problem or perfect problem of the artificial intelligence. Scroll. Scroll. So thank you all of you. Thank you very much for giving me the opportunity, all organizers. Thank you one and all.
With this, we bring keynote session 1 to a close. I would like to sincerely thank our esteemed guest, Dr. Nilesh Singh Thakur, for his valuable insights and contributions. Your presence has truly enriched this session, and we are grateful for the knowledge shared. Now I request Dr. Sandeep Petkar, Organizing Secretary, to present a memento to Dr. Nilesh Singh Thakur as a token of appreciation, followed by the distribution of appreciation certificate. Thank you, sir. Now, we move forward to the next segment of our event, Keynote Session 2. To begin this session, I kindly invite the following dignitaries to please come on stage. Now, we move forward to the next segment of event, Keynote Session 2. To begin this session, I kindly invite the following dignitaries to please come on stage. Our esteemed Dr. Rahul Khokle, Organizing Chairperson and Dean SOET. Dr. Naseema Cherry, Co-Chairperson of the conference. Professor Dr. Jatin Sadarang, Convener.
We are delighted to bring together experts, researchers, and professionals from around the world to share their knowledge, ideas, and experiences in the field of science and engineering. It is my privilege to welcome our chief guest and keynote speaker, Professor Dr. Sanjay G. Dhoble, a distinguished senior professor in the Department of Physics at RTM Nagpur University. With a career spanning over 3 decades, Professor Dhoble has established himself making significant contributions to the areas of solid-state lighting materials, photosynthesis, and radiation dosimetry. Throughout his illustrious career, Professor Dhoble has demonstrated a remarkable commitment to excellence in research and education. His academic achievements are truly impressive, with over 1,000 research papers published in Scopus Index journals and more than 18,000 citations on Google Scholar. His work has been widely recognized and respected by the scientific community for his contribution to research and development. Professor Dhoble's impact extends beyond his research publications. He has supervised 80 plus PhD students, many of whom have gone on to make their own mark in the field of physics. His dedication to teaching and mentoring has inspired countless students and young researchers, and his legacy continues to shape the next generation of scientists. I am particularly impressed by Professor Dhoble's recognition as one of the top 2% scientists in the world by Stanford University for several consecutive years. This achievement is a testament to his exceptional research quality and its impact on the global scientific community. Additionally, his inclusion in the top 0.05% in Scholar GPS at the world level in 2024 further underscores his standing as a leading researcher in this field. Professor Dhoble's contributions have also been acknowledged through various prestigious awards, including the Luminescence Society of India's Fellowship of the Maharashtra Academy of Sciences, the Research Excellence Award in Rare Earth, and the India's Top Faculty Award 2018 in Physics. His receipt of the late Dharnidhar Gandhi Social Teacher Award and Lions Iconic Award further highlights his commitment to societal impact and educational excellence. As an editor of Nature and Luminescence, the Journal of Biological and Chemical Luminescence, Professor Dhoble continues to play a pivotal role in advancing scientific knowledge and dissemination of his area of.
Thank you, sir, for the kind introduction. I know. And now I invite our esteemed guest, Dr. Sanjay Dhoble, sir, to begin keynote session 2. Sir, we are eager to hear your valuable insights. The stage is yours.
Good afternoon to all. Now, I'm very thankful to the all organizing committee members for inviting me for presenting my talk on a very important topic, multidisciplinary application of phosphor in science and technology. So this topic is based on my basic research on the luminescence, and some of the material emit the light by some process. This material is called the phosphor. So what is the application of the phosphor in the science and technology, and what is the beneficial of the student, all are contained in this my presentations. So just you can see here, first I'm introduce the phosphor. Phosphor means the luminescence material, and they emit the light. This is called the luminescence material. Just you can see how to explain this phosphor. Electron always present in the ground state, and this electron excited by a higher energy level. So this electron excited by a higher energy level, and this is the energy is the Hν photon. So this photon energy absorbed by this electron present in the ground state, and it is the excited state. Then this excited electron not possible to stay at the higher energy level, again come back to the ground level. So during this emission of the during the comeback of this excited electron, this emission of light in terms of the photon, this emission of this photon, it is called the luminescence. So this is a very simple explanation of this luminescence. And luminescence, it has so many applications, and all our applications are very important. But if you can work on this material, so it is possible you can do. This is the lamp, laser, display, TLD, LED, ink, dating, and all some of the application in the science faculty, some of the application in the engineering and technology also. So this topic is very interesting. You can do it the work. So now just some of the applications are just again consider indoor plant and this is the Li-Fi technology as well as to the indicate and display. But nowadays it is a very important application for the biomedical application. So now is the all engineering people also working in the biomedical application. So this is a very interesting application of this our material. Now just you can see on the basis of this application of this phosphor, I am working on the different topic. Just the LED application for the artificial lighting, it is called the LED. Second is the enhancement of the solar cell efficiency. So solar cell efficiency also you can enhance with help of the phosphor. Again, it is the TL radiation dosimetry for radiation dose measurement, IM beam irradiation, plant cultivation, fingerprint, useful for the forensic and CID applications. And just the long-lasting and road traffic, biosensor, antimicrobial activity, phototherapy, all are the biological application, mosquitoes repellent lamp, machine learning, also I'm working on the machine learning also, radiation dosimetry in the geological subject, biomedical device, fabrication of the device for the Ayurveda and other subjects also. So with help as per the given luminescence emission of the light, and this is the very important, and this is called the multidisciplinary application, and each application we have to publish the paper, patent or book chapter like this one. So just you can see the preparation of the material is possible by some of the illustrative method, wet chemical method or novel synthesis. So these are methods are very useful for synthesis of material. I'm shortly explain just the combustion method. In this method, it is the all nitrate based compound you can use, heat at the 550 degrees centigrade, and this type of the flame is observed. At this flame, this material is completely prepared. So furnace temperature 550, but this flame temperature 15 to 1600 degrees centigrade, and this material is completely prepared at the high temperature. So this is the novelty of this combustion synthesis. Second, it is a different type of the fuel you can use. So morphology material, it is also the changes. Third one, it is the synthesis technique. Just you can solute synthesis. This method is completely devoted by synthesis of the novel nanomaterial, and by using the tetraethoxy orthosilicate and ammonia, and this material is prepared by solute combustion synthesis. Now solid state diffusion techniques is very important. All this material you can prepare by the oxide, carbonate, any type of the starting material is the double heating path, and just you can prepare this material in the micron size of the material is possible by this one. And last is the wet chemical synthesis, very important. Here is the very low cost, you only require the Borosil beaker and distilled water, and just you can prepare very short way by this wet chemical method. This is the novelty of this synthesis. But if you want to prepare the material by waste material, this is the agricultural waste or this is the biological waste, that it is also possible you can prepare the material. This agricultural waste of the just biological waste is useful for the calcium oxide. Similarly, it is the rice husks also useful for the silicon material. So if you can prepare the calcium silicate, so then it is very important. So some is the calcium is outside possible by the biological waste eggshell, and this is the rice husk by SiO2, and this type of the compound you can easily prepare. So this type of the quality is possible in this material, and this is the synthesis of material is very important. And even characterization of the material, it is important. Spectrophotometer for the luminescence characterization, UV visible, thermoluminescence reader, spin coater, and this is the characterization again the magnetic stirrer, centrifuge machine. This is all these are required for synthesis of material, as well as to the this is the characterization by ACM, XRD, TAME, and all this thing. This all facility is available as a centralized facility. So there is no any question of this one. Now I'm explain the one by one. It is the application of the LEDs. So preparation of fabrication of the LED and preparation of the material of the LED application. So just you can see this is the LED. It has the diode. It has the our phosphor material, and this material prepared in our laboratory by different way and very low cost synthesis. So what is the LED is important. LED is the lifetime is the 1,000 years, 1,000 hours. It is a very small scale, 90% power saving, and there is no mercury. Then this is called the eco-friendly lighting, and this LED it is the best as compared to the other lighting sources. So I'm working on this LED material for preparation of this material. Just you can see the if you prepare the white material, so it's required the blue color, green and red color. All this combination of these three color white LED is possible, but nowadays it is the blue and yellow. It is also completely possible the white color. It is called a two color LED. But now you can excited by the near UV light and all combination of the blue, green, red. It is the white LED is possible, and all this material prepared in our lab by with the different type of the synthesis. So this blue, green, red, it is the white emission is possible, and this is the available in this market. And individually or white light, both are the possible by preparation of this material. So this material is prepared in our laboratory by different synthesis route. But under the UV light, this light emit the blue color. This one material is the green color. This is the emit the red color. This is the emission of light. It is the totally depend on the which activator present in this material, and this activator show the characteristic of the emission of the light. And according to the emission of the light, you can find out that it is the application. So all these things are important. So for this purpose, we are using the mainly periodic table. This is the rare earth ion. Just you can see this row is completely rare earth ion. These are show the luminescence characterization, and this material are very useful for preparation of this material. So just you can see out of this europium, Ce, divide, Tb, and Sm, all this type of the material rare earth iron useful for the down conversion phosphor, and with help of the you can prepare some of the LED material. And for the host material, just you can use the aluminate, borate, fluoride, nitride, oxide, phosphate, sulfate like this one. So this is prepared, and this is the excitation of the Indian gallium. You can use the aluminate, borate, fluoride, nitride, oxide, phosphate, sulfate like this one. So this is prepared, and this is the excitation of